Athlon worksheet, detailed answer for worksheet number 7. Worksheet number 7. So we have this function. How do we know it's a function? Because we see f of x. F of x is just like us running y. So when we see f of x equals x cubed minus 6, that's just like seeing y equals x cubed minus 6. They both have that same meaning. It's the function of x, and that's what our variable that we have. So it says x equals 5. So we can actually say f of 5, because that's what we're plugging in for x, equals 5 cubed minus 6. Orders of operations, 5 cubed is 125 minus 6, which is 99? No, hello, 99, nice, is 119. 119. So technically f of x equals 119, or f of 5 equals 119. Number 2, x is a negative. So when we plug in -3, and the nice thing about writing in this fashion is we know what our x value. That's our x value. So we know what we're plugging in. So we would have to write -3 cubed minus 6. We would need to write that with parentheses. And this is where all of this work all of a sudden becomes very weird and technical. Our exponent is 3, and our base without the parentheses means we have 3 3's. And then that negative is not included in that exponent. That's why this is different. So this would give us -27. But if we have -3 to the third, that's a completely different calculation. It may give you the same answer. 3 is still our exponent, but this time our base is -3. So the negative is included because we see it in this manner. So it's -3 times -3 times -3, which is -27 still, but a different way of getting it. So when we see this, our x value is being cubed. Our x is -3, so x cubed is equal to x times x times x. And if x is -3, that would be -3 times -3 times -3. So this would still produce -27 minus 6, which is -33. So f of -3 is -33. Fraction, also very important. We would need to, when we write f of 1/2, that's going to need parentheses. And I'll show you back on this page why you need parentheses, because there's a huge difference between 1/2 cubed and the quantity 1/2 cubed. This is equal to 1 times 1 times 1 over 2, or 1/2, because the exponent is 3, but the base of that exponent is only 1. So when we see it with parentheses, the exponent is 3, but the base is now included, both of them. So 1/2 would be 1/2 times 1/2 times 1/2, which gives us 1/8. So this is going to be 1/8 minus 6, which is -5 7/8, equals f of 1/2. -5 7/8. So that's a little tricky. Rad 2, ooh, such a good one. So we have rad 2 cubed minus 6. So that's rad 2 times rad 2 times rad 2. Remember, there's a 2 in there. So 2 rads are going to cancel. So you get 2 rad 2 minus 6, which is your f of rad 2. We can't combine these. These are unlike terms, and we can't combine their coefficients because that's this is an exponent. Don't know if you know that the square root, I think we talked about this, that's can be written as 2 to the 1/2. That radical inside there is in the denominator. There's an invisible 1. So when we see the square root of 3 to the 4th, that can be written as 3 to the 4 over 2, or 3 to the 1/2, or 9. Well, let's think about that. If we have 3 to the 4th, square root of 3 times 3 times 3 times 3, and we can do 3 squared times the square root of 3 squared, because we have 2 of those. And these cancel, cancel, cancel. You're left with 3, cancel, cancel, times 3, which is 9. So lots of different ways. And this would be exponential notation, and this would be radical notation. So when we have that square root of 2 to the 3rd, 2 of those 3 will pop out. One of them will pop out. So that's a real good problem. So this time x is equal to 2t cubed minus 6. Now we cannot distribute across exponents across addition, subtraction, but you can distribute it across multiplication. So that simplifies to this, and you get 2/3, which is 2 to the 3rd, 8t cubed minus 6, which would be your answer. F of 2t is equal to 8t cubed minus 6. And what I mean by that is when you have 3m squared p to the 3rd to the 2nd, you can distribute that to each of them. So that's 3 to the 2nd times m to the 2nd times 2. A power of a power is multiplication, and p to the 3 times 2. So this is 9m to the 4th, p to the 6th. Now, if we had m plus 2 to the 2nd, you cannot distribute. That is a no-no. You cannot distribute across addition and subtraction. No, cannot distribute. We would have to use FOIL. So the way we do that is the exponent is 2, and the base is this whole entire thing. So I have 2 of those. So we can simplify that by writing them out like this. And then we would FOIL or double distribute. So we distribute the m to the m and the 2. We distribute the 2 to the m and the 2. And you should be able to write this really quickly. You should be able to know how to multiply binomials. You want to do well in the academic decathlon? Know you're multiplying by binomials. So that's a good one. Evaluate, find. So now they say, hey, this equals this. So when we have f of x equals x to the 3rd minus 6, we're going to substitute this value in for this. So where we see this, we're going to write 337. So 337 equals x cubed minus 6. Let's isolate the variable. Let's add 6 to both sides. We get 343 equals x to the 3rd. I'm going to say it's 11. But what gets rid of a cube? Yes, a cube root. So we're going to take the cube root of both of those, and you get, pretty sure it's 11. So you can type 3, 4, 3, and we can take the cube root. Oh, 7, way off. So it is 7 equals x, and that would be my answer. So you see how you can get rid of a cube. Okay, new one. So now g of x. So g of 8 equals 2 times the square root of 8 plus 1. G of 8 equals 2 times the square root of 9. Square root of 9 is a perfect square, and that is 3. And we get g of 8 equals 6. So this time x equals 6. So g of 6 equals 2 times the square root of 6 plus 1. 6 plus 1 is 7. Square root of 7 is, it can't be simplified, so you would leave it as 2 rad 7. So x equals t squared. So g of t squared equals 2 times t squared plus 1, and that can't be simplified. That cannot be broken up. So remember, when we have, let's say 25t to the fourth, square root of 25 to the t fourth, because it's being multiplied, we can break those up into their separate square roots, and we get 5t squared. But if we have something being added and subtracted, like t squared plus 9, we cannot break those up. You cannot separate. Even though both are perfect squares, we can't do t plus 3. So do not separate. There is a little bit of a tricky one, but that might come later. So that would be my answer, because I can't separate the t squared and 1, even though both are perfect squares. Let's plug it in. So we have g of negative 3/4 equals 2 times the square root of negative 3/4 plus 1 equals 2 times the square root of 1/4. And notice everybody would stop, but remember, division and multiplication you can write under your own radical. And so square root, and this is times, not a mixed number, that's times, that was bad, I should write times. So the square root of 1 is 1, square root of 4 is 2, so we have 2 times 1/2, which is 1. So f of negative 3/4 actually equals 1. That's a good one. So do not write 2 and 1/2. That's, students are going to add that, or they're just going to plop that to the right of the 2. That is the tricky one. So we have 2. Now you could either simplify that now, or you could have simplified it inside it. But we would write 4 plus 1, and we get 2 rad 5, which cannot be simplified. So g of, I don't know, you can write square root of 16. I probably wouldn't. I'd probably just write g of 4. We have g of x. Oh, so now we again have my g of x. So this is equal to, this is equal to 10. So we're going to set it equal to 10. So we have 10 equals 2 rad x plus 1. So let's isolate the radical. We'll divide both sides by 2. And we get 5 equals square root of x plus 1. What gets rid of a square root is a square. So we're going to square both sides. And we get 25. I don't want it in green. 25 equals x plus 1 minus 1. And we get 24 equals x. So we can check that. If we plug 24 into x, 24 plus 1 is 25. Square root of 25 is 5. 5 times 2 gives me 10. So that is a nice little check. So my answer is going to be x equals 24. Warm-ups. So -1, we're going to plug in for x. So, and find out, oh, well, actually, yeah, we did that, and then we have to do the next one, which is 0, sorry. So if we plug in -1, 2 times -1 plus 1 is -2 plus 1 is -1. And yes, y equaled -1 when we plugged in -1 for x. But this is what they want us to do. Let's do it for 0. So y equals 2 times 0 plus 1. Y equals 0 plus 1, y equals 1. So when x is 0, y is equal to 1. Let's do it when y equals 3. So this time we're going to set y equal to the 3, because that's my y. 3 is in my y value. And then we're going to solve. Minus 1 You get 2 equals 2x. Divide by 2. We get 1 equals x. So when x equals 1, y equals 3. And the last one, let's do 2 in for x, because it's in my x column. So y equals 2 times 2 plus 1. Y equals 4 plus 1. Y equals 5. So my y value is going to be 5 when my x value is 2. And 3, we're not done, sorry. Now we're going to plug 3 in for x. 2 times 3 plus 1, 6 plus 1, 7. So when x is 3, y is equal to 7. Boom. That was a nice fast one.